My name is Aleksandar. I'm a freelance software engineer from Serbia, and I'm mostly interested in Scala and functional programming, of course. I'm currently working with a company called Blue Labs, and we have quite a few openings. We have Scala, Go, and infrastructure engineering positions open. Regarding Scala, we are using Akka, Monix, Cats, ZIO, basically everything. It depends on the team. And if you want to build sports betting platform in a fully remote team that is spread across Europe and to use functional Scala, feel free to apply at this website, bluelabs.eu. Here, just I forgot to mention that besides Scala and functional programming, we also use Apache Pulsar as a messaging platform, and everything is deployed on Google Cloud Platform and Kubernetes. Here is a plan of what you're going to learn in the next 20 minutes. First, we are going to explore one example of microservice architecture that I've made up for this talk. After that, we will briefly discuss some of the most popular messaging solutions, some pros and cons, and see why Apache Kafka is probably the safest pick at the moment. The next thing on the menu will be ZIO, where we are going to see some of the most common patterns that are used while building ZIO-based applications, like configuration loading, dependency management, error handling, concurrent and parallel programming, safe resource management, and everything will be supported with code snippets. Let's get started. Here's the architecture diagram of the microservice system that I prepared. We have 3 services that are written in Scala and ZIO, and they use Kafka topics to communicate between each other. We have ingestion service, which is basically just an HTTP proxy to Kafka. It will receive some JSON payload, and it will just pass downstream to some Kafka topic. The next service in our pipeline is enrichment service, and it will constantly read messages from one Kafka topic. It will use some third-party API to enrich messages, and it will push to a new topic. And that enriched data will be consumed by aggregation service and stored in a certain way. Finally, we will, on top of aggregation service, we will expose HTTP API to be able to query those aggregated data. And here is the example of how our Kafka events looks. Basically, we have just some transactions that have a user ID, country, and amount. And when we enrich the message, we will have just some country details. And in our aggregation service, we will be able to query total amount spent by country, by user ID, by region, or by sub-region. First, before start coding, showing some code, we will discuss some messaging solution. The first one is RabbitMQ. It's old school. It's written in Erlang, and have a client library in virtually every language you can imagine. It mostly uses as a classical message queue, which is just a sequential structure. You have producers that add data to the tail of a queue, and you have consumers that read that data from head of a queue. When message is processed, it's removed, and this is the major difference if you compare Rabbit to the Kafka or old Pulsar. But I think that RabbitMQ team will add append-only structure, or they already added to RabbitMQ, and also they will make non-destructive consumer semantics. Second one on the list is the Apache Kafka. I think it's the most popular messaging solution right now. It's written in Java and Scala combined, and it's basically distributed and replicated append-only log, which means that your data in Kafka can stay forever depending on the use case. And it supports only publish subscribe model. And that's can be a con if you compare it to the RabbitMQ, which have some pretty complex routing strategies. In Kafka, main concept is a topic, and you can use where all data is stored. You can use producer API to add data to a topic, or use consumer API to read from a topic. Data from Kafka is read sequentially by specifying consumer offset from where you want to start reading messages. And the offset is just a unique ID for every message that's constantly incrementing. And the third solution is Apache Pulsar. It's written in Java completely. It's have pretty similar API to the Kafka, but you can even use plain Kafka API with Pulsar because Pulsar team implemented Kafka interop library. It's great, and I think they're aiming to be better than Kafka, but I think it's really hard to achieve because Kafka is much more mature. It's have a much bigger community, much better documentation, and a lot of available learning resources. So it's going to be pretty hard to be better than Apache Kafka. The next thing we will discuss is the overview of ZIO-based libraries that helps us to build day-to-day applications. So we will start with ZIO config, since every application starting point is configuration. So if you're using Scala, there's a pretty big chance that you're using Hawkon style configuration files. And the standard library for reading Hawkon configuration is type-safe config. But if you are living in functional Scala land, it's definitely not your choice. You have a couple of options. One of them is pure config, which you can use to read and parse configuration files to Scala case classes, or you can use Cyrus to load the configuration directly from the environment. And if you want both of these features in one library, then ZIO config is way to go. Here is the example of configuration file in Hawkon format from one of our microservices that we described earlier. And this can be represented as a Scala case class with 3 fields, and every that field is a separate case class. So this is how it looks in the code. Now let's check the appconfig case class companion object and see how to load config, map row configuration to a wanted case class, and turn that into layer. So the first line, we have defined configuration descriptor, which is derived based on the appconfig case class, and it basically knows how to map row configuration to a given case class. Here is code that do all of the work. First, it will load row configuration for a from a file. Then it will turn our row configuration to the config source, which is internal data structure from ZIO config. And in the final step, it will use descriptor to map config source to our appconfig case class. After that, we will convert this effect to a layer, or we are going to kill the effect with or die operator if configuration loading failed, because there's no point to continue further if we are not able to load our configuration. And that's it. You just finished the ZIO config crash course. Now, let's check how we can use Z layers as dependency injection mechanism, how to access to specific service in the environment of some effect, and how to provide layer to effect with ZIO magic, because using plain ZIO with layers can be really hard. And fortunately, ZIO magic saves us from that work. ZIO magic will become it's already first class feature in the ZIO 2.0, but in my examples, I use ZIO 1.0 with ZIO magic. And it's such a massive improvement in terms of developer ergonomics. And before ZIO magic, I was really avoiding using layers, but now it's totally different story. Here is the simple ZIO application that will just print some configuration 5 times to a console. It's a pretty stupid application, but I think it's enough to show how to work with layers. So you can see that our program need app config and clock in order to be executed. And if you need some specific service from the environment, you can use ZIO service to extract it, and you can use it directly. Final step before we wanted to execute our program is to provide dependencies. So if you're using plain ZIO, you have some operators to combine the layers in a certain way, like this ++ operator, but it's not scalable, because if you have, for example, 20 or 30 layers, and sometimes even order of how you combine them matters, it's become pretty ugly and really hard to maintain. So recommended way is to use this inject extension method from ZIO magic that will magically wire all the dependencies in correct way, no matter in which order you provide them. And it can save you tons of hours making Z layers works. So again, thank you, Keith, for making ZIO magic. Next thing to discuss is how to build web applications with Scala. So in Scala, we have a lot of options to build web service, like Akka HTTP and HTTP4S, and I think they're the most popular right now. They are not ZIO native, but it's pretty easy to implement interop model with them. Fortunately, if you need to implement web application with ZIO, you don't need to use them anymore, because in the previous talk, we saw that Tushar presented ZIO HTTP, which is a solution for that. So let's jump to some example ZIO HTTP app. We will just implement a web application with only one endpoint that will always return response with status code 200 as long as our application is running. And generally, you can see here how it is intuitive and simple to implement HTTP endpoint. And in companion object, we are just creating our health check endpoint plus and making a layer out of it. Our application will need some simple configuration. Let's say that we just need the port number as a configuration. We'll just hard code it here and make layer out of it. And we will implement a web server class, which just need the HTTP config and health check routes enabled to work. It have only one method start, which is just a proxy method to the ZIO HTTP server start method that needs two parameters. The first one is the port number where our application will running, and another one is endpoints that should be exposed. Again, here in the companion object, we are creating our web server class and making layer out of it. And here is the entry point to our web application. We are extracting web server from environment of the effect, and then we are starting web server, which will run forever or until crashes. And in order to make compiler happy, we need to provide all the dependencies here. Again, we are going to use ZIO magic and inject method to provide all of them. It doesn't matter in which order we specify them, and that's it. Your web server is ready, and we have fully functional web applications. And I hope that you already captured the pattern, how we define services and how we make layers out of them, and finally how we just providing them in one place, which is entry point of our application. So general design with ZIO magic now is pretty clean. What else left is to explain how to use ZIO Kafka, which is my favorite Kafka client library, because it is pretty easy to use and allow developers to focus mostly on business logic instead of worrying about how to implement and test some really complex stream processing patterns. Like usually, if you have some Kafka pipeline, you would like to parallelize processing of a Kafka message, which is hard if you're using just a plain Kafka client. Or usually you will interact in the middle of your pipeline with some third-party APIs to enrich your messages, and there you have to implement some retrying logic. And we all know how it's easy to do it retries with ZIO. And finally, if you need some non-trivial batching patterns like aggregating upcoming elements to a given timeout, it can be really hard if you're not using ZIO Kafka and ZIO streams. And it's really bad to not use them because you are getting all of this for free, and it's battle tested. So those are the reasons to pick ZIO Kafka. And even if you are not utilizing ZIO fully, you can maybe consider just rewriting your Kafka parts to ZIO Kafka to make your code simpler and more reliable. Now let's see some ZIO Kafka code. Here's the case class that represent configuration of our Kafka consumer. And we have this method that will just turn our configuration to the consumer settings. And their consumer setting is ZIO Kafka internal class that is needed for us in order to construct Kafka consumer. And here in Kafka settings object, we are just turning our consumer settings into layer to be able to construct ZIO Kafka consumer. Now you can see how to implement simple Kafka stream processor. It needs a consumer instance and the consumer config instance in order to know from which topic to read. The most important method in this class is start method that will use consumer to subscribe to a provided topic. Then you have to specify deserializers for key value pairs that are coming from Kafka. And finally, here and map and par, you are ready to start applying some business logic to your Kafka messages. And map and par is, for example, operator from ZIO stream that allows you to parallelize your processing of stream elements. It accepts two parameters. The first one is telling us how many elements you want to process in parallel, and another one is a processing function, which will be applied to every incoming element in a stream. And everything below map and par is just a boilerplate, basically that's just commits offset to the Kafka, and it means that we are just telling Kafka that we received and successfully processed our message, and we do not want to receive this message anymore in this consumer. And yes, that's it. How it is simple to work with ZIO Kafka. Finally, let's see how you can combine HTTP server application and some Kafka processor and Kafka processing in the background. So here it is. We have a web application that uses both ZIO HTTP and ZIO Kafka. This is how it looks. We are extracting the HTTP server and Kafka processor from the environment, and we are just calling start method from both of them. Everything looks great, but when you start application, you probably will notice that your HTTP server only started, but Kafka processor not. So I guess you know what is the problem. Earlier, I said when you run HTTP server, it will run forever, but I forgot to tell that it will run on the main fiber, which means that this Kafka processor.start line will not be reached. And this is why it's not starting. So what is the solution? Solution is that we need to run both of these effects on separate fibers. And to run some effect on a different fiber, you just have to fork them, and that's it. The next step is to use ZIO Ray-Sol, which will execute all specified effects concurrently. And if some of the effects fail, everything will fail. But without using ZIO Ray-Sol, HTTP server may continue running, but our Kafka processor may fail, but we wouldn't notice it. So in a real world case, it's maybe better to kill the whole application if your background processing failed. And so to summarize what we have learned, we learned how to load and parse configuration using ZIO config. We learned how to implement simple HTTP API with ZIO HTTP. We learned how ZIO Magic simplifies our life when we have to work with Z layers. We learned some stream processing with ZIO Kafka, and we learned some concurrent and parallel programming with ZIO streams and ZIO fibers. Here, at my GitHub repository and my GitHub profile and the Functional Scala 2021 repository, you can find that example that I described before. So feel free to fork it or to make PR to make it better, and feel free to share it with your friends who are looking how to start building some real-world applications with ZIO. This is my social networks, and that's it. Thank you, everyone.